Yeah, so welcome on us to the topic of today. I'm teaching formula and variations. It's a topic in Form 3. It's a Form 3 topic, formula and variations. So in the lesson now, allow me to talk about formula. Let me talk about formula. So in this case, I'll help us understand what is meant by the term formula. And simply formula means it's an expression. It is a mathematical expression. It is a mathematical expression linking or joining two or more variables. That's simply what is meant by a formula. So I didn't understand that all along as a mathematician you've been using formulas here and there, and I'm going to begin with a very simple example of a formula. For example, i.e. you can have the formula of finding the area of a rectangle that is given by A is equals to length multiplied by width. Also, we have other formulas such as, for example, you can have the area of a trapezium, which is given by a half A plus B multiplied by height. So other formulas may include, I believe you've done the volume of a cone, for example, which is given by r pi r squared multiplied by the vertical height of a cone. We can also have another formula, a simpler one, area of a circle, which is given by area is equals to pi r squared, given by pi r squared. So precisely, those are formulas, and that is what is meant by the term formula. But then, as we advance, I want us to do something in matters formulas. For example, we have what we call expressing, or rather, making a variable the subject of a formula. The subject of a formula. So that is the first subtopic under that one. For example, let me just pick a simple formula such as area is equals to length times width. And you are told this question can be brought in two ways. You can be told to make W the subject of the formula that way, or rather somebody could tell you to express. You can be told to express W in terms of maybe A and L. So it's one and the same thing. It means the same thing. So in this case now, I want us to see how do we go about it. If you are told to make W the subject of the formula in such a question, so simple. So A is equals to LW. Our point of interest is this letter W, because we are told to express that particular formula, or rather express W in terms of other variables present in that formula. So in this case, I'll have to divide both sides by L. So at the end of the day, we find that this cancels out. We find that W is given by area divided by length. That's example number one. So we can have example number two. Allow me to do another one, example 2. Let me have example 2. Example 2 here. And this example, allow me use the area of a circle, which is given by area is equals to pi r squared. And in this case, you're told to express r in terms of pi and area. So how do we go about it? So in this case, I'm going to divide both sides by pi, this side by pi. So in this case, that cancels out. I end up with r squared is equals to area over pi. But remember, we are interested only with W. So this is what we go about it. I want to get rid of this square. So get me right. if you're given a square and you want to get rid of that particular square, you introduce a root. So I'm going to introduce a root there, a square root there, and a square root on that other side. So in this case, I'm going to find that r is equals to the root of area over pi. So allow me to show you another concept here. Assume you are given a cube. So how do you get rid of this cube? You simply introduce a cube root, right? So, and again, even if you're given maybe r raised to 4, to get rid of this fourth root, of this so apologies for that. So to get rid of this power, you simply introduce a fourth root. Well, another example, let's have example number 3. Let's have example number 3. In this example, allow me to use this formula of V is equals to pi r squared height. And in this case, told to make r the subject of the formula, or rather to express r in terms of pi, height, and volume. So simple, as you've said. So in this case, I'm going to divide both sides by pi and h. Also this side, I divide by pi and h. So I'm going to remain h goes, that one goes. So I'm going to remain the r squared is equals to volume over pi multiplied by height. But remember, I've said to get rid of this index or this number raised to r, I simply, because it's 2, I simply introduce a square root, and in this case I'll get r is equals to the root of r over pi height. So I want you to get now how I'm getting rid of that square there, of that index. So lastly, allow me to do this. You can also attempt this question together with me, and we're going to go about it in this manner. For example, let's have, this is our example number 4 and our last example in this case, but unless maybe you can leave a comment down there in case you have a query or further clarifications. So you're given t is equals to, you're told t is equals to 2 pi and then the root of L over G, and you are told to express G in terms of other variables present in that particular formula. So how do we go about it now? So in the first place, you can decide to get rid of this first part here, like I'm going to do. So I'm going to divide both sides by 2 pi, and on this side I still divide by 2 pi. So the outcome will be t over 2 pi is equals to the root of L over G. Step 1. So step 2 now, in step 2, I want to get rid now of this particular root. Like I said, if you're given a square root, you multiply, you open it using a what? A square. If you're given a cube root, you remove the root by adding a cube. So in this case, at this point, I'm going to introduce a square because we have the root of we have the sign of the square root. So and then also on this side, I square. So in this case, what I get, I'm going to have t squared over, but remember this root here, this square here is effective on these two variables here independently. So I'm going to have 4 pi squared. So this is a point of examination above an examiner is able to test you on. So is equal to, is going to become L over G. But keep in mind that G is our point of interest. So what I'm going to do is simply this. So I'm going to multiply by the reciprocal of L, which is 1 over L. What I do to this side, I also do to this side. So multiplied by 1 over L. So the outcome will be, that one goes, I'm going to have t squared, because of course if you have 1 times 2t squared is equals to t squared over L 4 pi r squared is equals to 1 over G. But remember, we are not looking for 1 over G. Okay, sorry, the r is not there. Apologies for that. So in this case, we're going to remain with t squared over L for pi squared is equals to 1 over g. But then our point of interest is g, not 1 over g. So in this case, I simply find the reciprocal of this one. So I'm going to have g is equals, if you have the reciprocal on this side, you also apply it on this other side. So we're going to have L for pi squared over t squared, and that's how you express g in terms of the variables present in the formula given. Thanks for watching. Remember to subscribe and remember to post any questions that you have issues with, and as usual, let's keep learning.